Hello, today we're going to be talking about the Algebra 1 Common Core Regents Exam from January of 2018. Just wanted to let you know I'm starting with a fresh graphing calculator. I reset it, pressing second plus 712. Okay, so let's take a look at some of the multiple choice questions. And I'll try to provide a link down at the bottom for you to get a copy of this Regents. You could also just Google it and you'll be able to find a file. So when solving the equation 12x squared minus 7x equals blah, 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 Evan wrote the following as his first step. Which property justifies this step? So we're trying to figure out how he got from his original to the next step in his problem. So if I'm taking a look, the 12x squared, the 7x, the equal sign, the 6 are all the same. What changed is the second part here. And what he actually did was distribute. So he did negative 2 times x squared to get negative 2x squared, and negative 2 times negative 1 to get positive 2. So that's going to be choice 4. So an example of what subtraction property of equality is when you subtract on both sides. The multiplication property of equality is when you multiply on both sides. Associative property is when you regroup your terms. And distributive property is as above. Okay, Jill invests $400 in a savings bond. The value of the bond V of X in hundreds of dollars after X years is illustrated in this table. Which equation and statement illustrate the approximate value of the bond in hundreds of dollars over time and years? So what I see is a whole bunch of equations that I can plug into Y1 and determine if our table matches. So what I like to call matchy-matchy. So I'm going to go to Y equals in our graphing calculator and start with our first example and type in 4 parentheses 0.65 to the x power, and I'm going to take a look at the table and see at 0 am I 4? Yes. Do I match with 5.4? No. So this is not the answer. So I notice that for my second, it's actually giving me the same exact equation, just knowing whether it's growing or decaying. So obviously choice 2 is not the answer. So for choice 3 and 4, it is, and I can type it in to verify. But now I need to actually determine, see right here they match, but I have to determine, is this growing or decaying? So this is growing because you see an increase as I move along in the table. So our answer is choice 3. This also comes from the equation of an exponential function where A is our initial and B is our multiplying factor. So our multiplying factor will be greater than 1 if I am growing, and it will be less than 1, like this point between 0 and 1, rather if it's 0.65 when it is decaying, so when I am decreasing. So how do we determine our multiplying factor? Well, you can actually take each of these two values and divide. So 5.4 over 4 is actually equal to 1.35. 7.29 over 5.4 is 1.35, and the same thing. So you can undo it by doing division to determine what you're actually multiplying by as you go forward in the table. Okay. If we take a look at number 3, Alicia purchased H half gallons of ice cream for $3.50, so that's how much the half gallons go for. And P packages of ice cream cones for $2.50, so that's how much the packages of ice cream go for. She purchased a total of 14 items and spent $43. Which system of equations could be used to determine how many of each item she purchased? System of equations, which means I'm going to have 2 equations. So I identify this by rewriting. So it's $3.50 per H, right? They're using H for the half gallons. And $2.50 per P for packages of ice cream. We have a total of 14 items. And we have a total of $43. So I like to say that all of the money goes together. So 350H and 250P and 43 should all go together. So that cancels out 3 and 4 because 350, 250, and 14 don't go together. All the money does. So we know that this first equation is correct. We know that the 3 numbers go together, but we have to figure out, do they match with who they're supposed to match with? So $3.50 per half gallon goes together, $2.50 per package of ice cream goes together, and then it totals 43. So this one is the correct answer. The second choice mixes them up. It says $3.50 per package of ice cream. Well, that's not true. It's supposed to be $2.50, so this one is also wrong. You also recognize that H plus P, H is the amount of half gallons and P is the amount of packages. So when I add the amounts of those packages together, I get a total of 14 items. So that's why choice 1 is our answer. All right, so let's take a look at example number 4. So for number 4, it says a relation is graphed on the set of axes below. Based on this graph, the relation is a function because it passes the horizontal line test, a function because it passes the vertical line test, or not a function. So just by looking at this, I know that it is a function, so that gets rid of choice 3 and 4. I know it's a function because when I have the graph of something, I can actually draw an infinite amount of vertical lines. And if my vertical line only touches the function once every single time, then you pass the vertical line test. So the answer is 2. So let's take a look at number 5. Ian is saving up to buy a new baseball glove. Every month he puts $10 into a jar. Which type of function best models the total amount of money in the jar after a given number of months? So I would actually test this out and I would write a table. So I have the month and then the amount of money in the jar. So when he starts at 0 months, he has got no money in the jar. Then after 1 month, he has $10. After 2 months, he puts another 10 in there, so now he's got $20. After 3 months, he's got $30. And 4 months, he has $40, and so on. So how do we determine which type of function this is? Well, a linear function will have a constant average rate of change. Okay, and an exponential function is going to have something that grows by a multiplying factor. So this is going to grow by like a rate of increase. So it grows by a percent, kind of like how interest works in your savings account, and or population doubling, and so on. Linear is something that's just going to constantly increase by the same amount every single time. So in this example, I have a linear function because it increases by 10 every single time the month increases by 1. So this is a plus 10, plus 10, plus 10, plus 10. So we can say, oh, that's 10 over 1, 10 over 1, 10 over 1, 10 over 1. And so obviously this is a constant average rate of change. Sorry about that. So that is going to be choice 1. Okay, so for number 6, which ordered pair would not be a solution to y equals x to the third minus x? So all of these are x's and y's. So we can go into our graphing calculator, type in x to the third minus x. And then I'm going to actually change my table setup. So I'm going to press second window and change my independent to ask. So I do this when I have values that I want to ask the calculator about. I want to tell the calculator specifically which values to look for. So when I go to my table, you'll see it's empty. It's not broken. It's purposely like that because I haven't told the calculator anything yet. So now I'm going to test each x value and determine if the y value does come out the way it should or doesn't. So I'm asking for which pair would not be a solution, so I should be expecting to see one of these not work. So I'm going to type in the x value -4, so I literally type in -4, press enter, and I have the matching pair of -60. Then I try -3, I also match. I try -2, I match again, and just to verify, I try -1. According to the calculator and the function itself, I should get -10, but the choice is -1, -2, so that is the incorrect answer. Okay, so we're actually going to stop there for now. This is only questions 1 through 6, and I will make another part that has the rest of them. Have a nice day. Bye-bye.